Roger, please tell me about Shine On You Crazy Diamond.
Shine On You Crazy Diamond. I wrote that song as a nod to Syd Barrett and Stellar Evolution. Syd Barrett was one of my good friends and founding member of the band Pink Floyd, and his life was very much so that of a star. He started off young and hot and burned for a good while, but eventually collapsed upon his own weight and stardom. Throughout the song, I incorporate and allude to many astronomical events that are in the stellar life cycle. And originally, when I composed the song, I did so in chronological order. But upon recording it for the first or second time with the band, we decided to chop it up and move some lyrics around to what sounded better. So today, I'm going to play to you the song as I originally meant it to be listened to. And after each verse, I'm going to describe to you what it means in stellar, what place it takes in the stellar life cycle, and maybe that of Syd Barrett. So for you and the audience, here is Shine On You Crazy Diamond.
Remember when you were young, you shone like the sun. You were caught in the crossfire of childhood stardom, blown on the steel breeze.
This first verse details stellar birth and the early stages of life for a low-mass star. The line, "You're caught in the crossfire of childhood and stardom," describes a protostar. This is the earliest stage of stellar evolution, when a very young star is still gravitationally attracting mass from its parent molecular cloud until it gets massive and dense enough to begin hydrogen fusion at its core. The crossfire, seen as a protostar, simultaneously attracts material while also ejecting it. This stage usually lasts around 1,000,000 years. The line, "blowing on the steel breeze," is a representation of a protostar becoming a pre-main sequence star. This begins when the protostar begins to blow back the infalling gas after fusion is ignited, revealing a large pre-main sequence star and initiating the solar wind. The beginning of this verse alludes to the prolonged life low-mass stars have as a main sequence star, like the Sun, whose primary energy source is hydrogen fusion and primary composition is hydrogen and helium. For stars like the Sun, this stage usually lasts around 12 billion years.
Come on, you target for faraway laughter. Come on, you stranger, you legend, you martyr, and shine. Well, you wore out your welcome with random precision. Rolled on the steel breeze. How many more layers? And I'll be joining you there.
Come on, you stranger, you legend, you martyr, and shine was originally a reference to when a star begins to move through the subgiant phase as it becomes a red giant. This occurs when the star cannot maintain hydrogen fusion in its core. Gravity will win and pull the core in with surrounding hydrogen layers, igniting hydrogen fusion around the core. The shell will burn much faster than the core and produce much more energy, causing the star to become larger and much more luminous despite the core shrinking. You wore out your welcome with random precision is meant to be when the star begins helium fusion through the triple alpha process. The hydrogen shell in the red giant adds helium to the core, which increases gravity. Eventually, the gravity will be enough to start helium fusion in the core. The degeneracy pressure will stop the core from shrinking until thermal pressure regains dominance and causes a helium flash that will let the core grow once again, allowing the outer layers to shrink as the hydrogen shell fusion and luminosity decrease. Pile on many more layers, and I'll be joining you there alludes to the double shell fusion star. Similar to when it first became a red giant, the star will ignite helium fusion around the core and hydrogen fusion in a shell outside of that. The two layers of fusion will make the star increase in size and luminosity to a point that the outer layers of the star are no longer stable. This will continue until fusion in the star cannot continue and the star will eventually die out.
Shine on, you crazy diamond, and we'll bask in the shadow of yesterday's triumph. Sail on the steel breeze, threatened by shadows at night, and exposed in the light. You reached for the secret too soon. You cried for the moon.
The line "rode on the steel breeze" refers to the pulsing of a low-mass star about to collapse. Due to double shell helium fusion, the star will continue to expand to a size that is too big to maintain. At this point, it will have a very weak hold on its outer layers. Because of winds, the star will eject these outer layers into space, revealing an exposed core that emits ultraviolet radiation. This is captured by the line and sail on the steel breeze. This radiation ionizes gas in the expanding shell, causing it to glow brightly in space. This phenomenon is known as a planetary nebula and is described in the song as the shadow of yesterday's triumph. After this nebula cools and fades, a small carbon core is left behind. This carbon core is called a white dwarf. The title of the song, Shine On You Crazy Diamond, is a direct reference to this carbon state of the white dwarf. White dwarfs are small in radius and are quite hot, reaching temperatures of 100,000 degrees Kelvin. Just as the planetary nebula did, over the next few billion years, the white dwarf will cool and fade from view. This completes the life cycle of a low-mass star.